Now, I don't actually want for this to be a continuously emitting smoke. What we'll be creating is a way of this kind of. My goal is what I want is to have a source that emits a ring of smoke from time to time. And let's see how we can kind of automatically animate that. I'm gonna hide this. I'm just gonna create here a sphere so we can go over a few interesting concepts. I'm also gonna unlock the view to the camera so that we can bring this out. And for now, I'm gonna turn off the lights. Okay, so I have here is a sphere. So what I'm going to be doing is I'm going to use the sine function to animate the density. And I just want to use this sphere demonstration to show you how the sine function can work. So if you use the sine function using the time, based on time, you will get some motion, but it's going to be too small and too slow. So what we can do is speed up the waving motion and also multiply that the size of it. So for instance, if I want to speed up, I need to multiply the time by something, by a factor of 10, for instance, and it's going to be 10 times faster. Let's make it 90 degrees. And we'll have this kind of wavy motion. So at frame 24, we're at 1 second, and the sine of 90 degrees of 1 times 90 degrees is going to be the sine of 90 degrees, which is 1. Then we move on, the sine of 180, which is 0, sine of 270 is going to be minus 1, and so on and so forth. Okay, and we get this kind of wavy motion. If we want, we can speed this up even further, using 180 for instance, and we'll get something like this. It's going to be much faster. Now, how can we grab this? Right now the values are going from -1 to 1. If we put ourselves on a side view, you'll see it's going to go from -1 to 1. The center of the circle, let me just reduce the scale. Okay, 0, 1, -1. But I just want the density to go between 0 and 1. 0, 1, 0, 1. So what we can do is we can use a fit, but instead of using a fit 0, 1, we'll just use a fit, and the fit allows us to establish the incoming values, the incoming range. In this case, it's going to be between -1 and 1, and I want it to be between 0 and 1. Okay, so that's what we're going to have, 0 and 1. This is the basis of what we're going to be using for animating the density automatically. So we're going to use an expression similar to the one we had on the circle, on the sphere, to animate the values of the density that we have here. I'm going to create a point wrangle, and on this point wrangle, I'm going to say that the color, let's say just add color, is going to be equal to fit. We want to fit the sine function of the time times, and the values that the sine is going to read here are different from the values that were being read on the expression. Here it's in radians, so we can't just use 180 degrees. We would have to use something like 2, and we want to fit what's coming in of -1 to 1, and we want to remap this from 0 to 1. Okay, so now if we have a look at the color values, just had to put a float there. Okay, and we get this type of animation. So 2 is actually too slow. Let's switch this to 5. Okay, we have a nice wavy effect that we'll use to generate some rings. So what we need to do is multiply the density that we have by this expression. So let's say float density is going to be time equals this. And here on the noise, I'm going to put this back to density and temperature. Okay. And now if we go to the volume, we should see that it goes black and then it goes up, darkens and then goes up. Okay. Now the problem we have here is that it's a very smooth gradient that's going from 0 to 1 and 0 to 1. Again, we can have a look. So it should be more black, white, and not a soft transition between the two. So what we can do is we can kind of do a channel ramp. I'll call dance ramp using the expression that we have, and that way we can remap what's coming in. Just click the button to generate the channel, and you'll see that we can kind of just say everything that's below this value should be black, and everything after this, it should be white very suddenly. Okay, and we should get something like this. Okay, it should be more kind of in, yeah. Okay. So this will be generating the rings first. Let's see how this works on the simulation. Go back to the camera. I'm gonna hide this. One ring, another ring, another ring. Yeah, so this is what I was going for. This will be a good exercise for us to be able to kind of have a look at what all the parameters do, and it's an interesting type of motion.